So for significant figures, it's related very much to uncertainty. And I love, I love this drawing, this picture here of Keanu Reeves. You know, you're supposed to round something to four sig figs. What do we mean by this? I think a lot of people spend too much time worrying about, you know, how many significant figures to use. A good rule of thumb is to actually use the least good one. So what I mean by that is if you've been given a whole bunch of different values. So this has to do with making measurements. So let's just say, or you know, using values on on exams. So let's just say you have different choices. You have like 2.0 is one of the values you're given, and maybe like 17.458, and maybe you're given like yeah, just these two, for example. Let's just say these are the two numbers you used in an equation in order to actually solve something. Then what you would do is when you're finished with your answer, if you got an answer that had a whole bunch of different digits like this one right here, like this 17.458, you would actually use only two right here. So you'd only use these two right here. You'd have something point something else. That's the main thing really to worry about as far as significant figures go. Just use the least good one. I think that's sort of a good rule of thumb here. So what do I mean by significant figures and uncertainty? When you're actually making a physical measurement, so let's just say you measure like the length of my, I don't know, this right here, whatever this is. Let's just say it's the length of, I don't know, an eraser or something like that. When you make a physical measurement, that means that you measure it with something, some device, and that means there's going to be some uncertainty on the actual measurement. In other words, you don't know it exactly. You might say it's like 5.8 centimeters, but it's not exactly. It's plus or minus a little bit. So this plus or minus implies the sort of shaky nature of measurement. So for example, I just want to focus on one thing, especially for the IB physics here, is usually the uncertainty is just one non-zero number. So what do I mean by that? I mean that, you know, later on when I show you, in videos how to actually calculate uncertainties, you might end up calculating something with a whole bunch of digits. So for example, let's say you get something that says like plus or minus 0.052 like I have here. This implies that you're so certain about your uncertainty. So, which is a little bit weird and counterintuitive. So what I like to tell you is for this one here, what I would probably do is think about this and say, okay, you just need one non-zero number. So in this case right here, I would just need the 0.05. So that would mean I would have to actually round this right here. My uncertainty itself, I need to make it, I'm only allowed one non-zero number. I'm allowed zeros to the left, I'm allowed zeros to the right, but usually that's how we write uncertainty. So in this case right here, I would write 0.05, and I would think about rounding. Do I have to round that number up or down? In this case, I don't. So do you see, the first thing I always check for is, does the student have one non-zero number? So in this case right here, yep, good. So that's a properly written uncertainty. Let's say you did another calculation and you got this like plus or minus 15.29. What do you do there? You're only allowed one non-zero number. So what I would say is you'll probably have to round on this to tens digits, so to speak. And that means I would either make it 10 or maybe 20. And it depends how you like to do your conventions here, but most people will say that a 5 afterwards will make it round up. So in this case right here, you'd end up with plus or minus 20, whatever these units are. And the reason I know this is okay is because, see, I've only got one non-zero number. What I like to tell students, we go more detail like this. I say, make a non-zero number sandwich. So if there's a whole bunch of, things in between like this right here, you would do this. That would be sort of for the significant figures. But I wouldn't worry too much about it. The key thing as far as your exams go is worrying, knowing how it is to actually write these uncertainties. So first of all, make your uncertainty a non-zero number. Next, once you know the uncertainty is a non-zero number, it's the uncertainty that drives how many significant figures you should use, not the other way around. So I'll give you a few examples. So let's just say here, I just wrote out a couple here. So let's just say we have, let's say you did a measurement and you actually measured through some device or something like that, some length, let's just say, is 2.128427 meters. You measured it somehow super accurately according to your little device that you used. But your uncertainty is 0.001 meters, let's just say. So first of all, you need to check, I want to write down this value. And let's just say I want to write down the length. Let's just say I want to say, all right, the length is going to be, this number, this 2 point whatever. Don't just say this plus or minus 0.001 and say you're done. Because you see, there's a problem now with how many significant figures you're allowed to use. Or in this case, I like to think of it as how many digits you can use, how many numbers you can use to represent this. You're always allowed to use you're always allowed to use scientific notation. So what I would do here, for example, is look, okay, first of all, is my uncertainty one non-zero number? Yes, it is. Now, do you notice that it's the third digit after the decimal? See that? After the decimal, it's 1, 2, 3. So that means, remember I showed you before here, it's the uncertainty that tells you how many significant figures to use. So in this case right here, I'm allowed 3 after the decimal. So I have to round here. So what that means is I can say my value is L equals 2.128. I have to stop there. I would round up or down. In this case here, I just leave it. Plus or minus 0.001 meters. Let's just say this could be a measurement. And this actually could be my answer. This could be my final answer. I could say, all right, that's it. Because if you're checking if someone did it right, you first check, is it one non-zero number? Yes. Are you rounding on the same digits? In other words, 3 after the decimal, 3 after the decimal? Then you got it. Let's look at the other one here. Let's say you make a measurement of force, and somehow you measure it or you calculate it. You know, when you're actually using your calculator, you actually type it all in, and you end up with a number of 259.4, right? Because that's a measured thing you can get. But your uncertainty is supposed to be plus or minus 10. So what do you do? This is for newtons. Again, you don't just say plus or minus 10 right here, right? You don't actually say just that, right? You can't just say that. You have to write it properly. So what I would do is I would say F equals, and think about this, 10, that's rounding in the sort of tens digit. So that means I have to round here, you know, because this is 259. So that means I would have to round here. So I'll write my 2. And my 5, however, though, will round up. Do you see that? Because the 9 makes it actually round up. So that means it becomes that 6. And I'm only allowed a 2 and a 6. I can't use any other numbers to represent it. The rest of it just has to become zeros. In this case here, it's just going to be 0. Now, I don't say 0.000, something like that. I'm not allowed that many digits. So I just say 260 plus or minus 10 newtons, and I'm good to go. So this right here could be my answer. So I hope this explains it. It's a really, really simple concept, but a lot of people mess it up. And just so you know, this shows up, this is immensely important for paper 3. Because the first part of paper 3, you have to do a lot of this sort of calculations, and it really helps to be able to understand how to actually represent your answer.